Hello and welcome to the next tutorial on IXP Manager. This one is going to be about connection management, which means managing your members' connections into the exchange, the ports, the interfaces, IP addresses, things like that. I'm recording this in August 2020 from sunny Dublin, and you're all very welcome. I'd like to start by just showing you our new website for those of you who haven't seen it. This went live in June if I remember correctly, but what I want to show you on this is on our support section, we have a tab for tutorials, and this is where we are accumulating all of these video tutorials into different courses. Of course, they're always available on YouTube, but as time goes on, we may re-record some of the older ones. And when we do that, we will probably stick to this structure and we'll reference the new ones here. So for example, we might slot in a new tutorial for the manual installation of IXP Manager if things change. And that will be reflected by this one here. Okay, hi and welcome again. So what we're going to do here is I'm going to log in to IXP Manager, which is the same one that we've been using in the tutorials to date. And if you remember at the end of the last tutorial, which was about customer management, what I did was I deleted the Facebook account, which was a sample user we added. All I've done since then is I've added that back in so that we can give Facebook some connections into our SCIX, our Some City Internet Exchange. Now, before I dive into what we do in IXP Manager, what I want to do is I want to give you a quick presentation on the database structure of how we manage interfaces in IXP Manager. And what's interesting about this, and I don't want to date Nick Hilliard, who was INX's CTO and the co-creator of IXP Manager, but the structure we're about to look at was created by Nick. I think, again, I don't want to date him, but I think it was over 15 years ago. And what's impressive with his structure and schema from then is that it has stood the test of time, that it has changed very little in all of that time through all of the versions of IXP Manager. So you can certainly take it that it's an incredibly stable schema that we use for managing this. So there's only a few short slides, and they're all. It's just it's not a presentation, but it's more of a diagram, a database diagram. So if you remember when we first installed IXP Manager, we created some of the objects that we need as part of managing an exchange, and they were things like our infrastructures, our VLANs, our IP addresses, and we also added some switches wherever they are, some switches and some switch ports. So we added an infrastructure, and if you recall, an infrastructure can have one or more VLANs. So that's sort of a one-to-many relationship here. A VLAN will typically have many IPv6 addresses and many IPv4 addresses. And in the last presentation, we added our member, which was Facebook in our example. So now what we want to do is we want to give some connections, some interfaces, some ports to that member. And the first thing we do in that is we create what we call a virtual interface. And as we'll see, a virtual interface is like database syntactic sugar. It's a means to collect the different objects that represent a member's connection into the exchange. So for example, one of those objects will be a physical interface. And a physical interface will record, for example, the member's speed, the speed at which that interface should run at. It will record the status. Is it connected? Are we awaiting a cross connect? Is it in quarantine? A physical interface has a one-to-one relationship with an actual switch port, and obviously a switch will have many switch ports. You might recall as well that when we added a switch has a relationship to infrastructure as well. So a switch belongs to an infrastructure, and as you might recall from those earlier presentations or video tutorials, in infrastructure you should think of like an IXP. Your IXP Manager can manage multiple infrastructures. So for example, for INX, we had INX LAN 1 is an infrastructure, INX LAN 2 is an infrastructure, INX Cork is an infrastructure. So it's only logical that all of the switches that participate in INX LAN 1 are linked to that particular infrastructure. Now, we will have members that will want a lag. That's multiple ports connected at the same speed, so maybe 3 10 gig ports to give a 30 gig connection to the exchange. And the way we manage lags, as we'll see, is we add multiple physical interfaces which connect to switch ports, which connect to a single switch. We don't do multi-switch lags. So we connect multiple physical interfaces to a virtual interface. And that's how we create a lag in the database schema. The next thing you're going to need is you're going to need a VLAN interface. So the physical interfaces represent the layer 2 side of a connection. The VLAN interface represents the layer 3 side of a connection. I appreciate it might be going a little bit fast, but again, this is a video tutorial, so please feel free to pause, rewind as necessary. Your VLAN interface will connect to a very specific VLAN. So for example, INX LAN 1, the peering VLAN for INX LAN 1. And your members connection will probably have an IPv4 and IPv6 address. So they're all connected here. There are cases where you might have multiple VLAN interfaces. In that case, as you can imagine, your physical interfaces become tagged 802.1q VLAN tagging. If you just have the one interface, which is typically the default, there's going to be a standard interface with no VLAN tagging whatsoever. It's not necessary. So that is the general structure of how we manage interfaces in IXP Manager. And we're going to see this a couple of times as we go through the UI, and I've got my database connection and my GUI interface to the database running as well. So we're going to take a look at how when we add these things into IXP Manager, how it affects those database objects, just to try and reinforce the structure that we're looking at here. Because I think it's really important that if you understand the structure and how it's laid out on the database, the UI becomes much more intuitive for you in day-to-day usage. I just want to point out two more things that we're not going to get into the weeds in today, but we do in IXP Manager record MAC addresses as well, and there's two ways we did that, and this is all in the documentation. Traditionally, there's what we call MAC addresses, which connect to a virtual interface. And the way MAC addresses worked is we had a script that went off to all of the switches and found what MAC addresses the switches had learnt for each port and how they related back to a virtual interface. And that's a read-only table in IXP Manager where we can see what the switches are learning. The second one, the one that we use more nowadays, is more around provisioning and static layer 2 ACLs, is we actually tell IXP Manager it's these layer 2 MAC addresses that should be associated with this VLAN interface. And then when you're doing your provisioning, your automated provisioning, and you're creating your static layer 2 ACLs, you can pull this information directly from IXP Manager. So this one was discovered on the switches and is available as read-only in IXP Manager. This one is set by the operator and is pushed to the switch in a provisioning process that we can look at in a future video tutorial. So that's that. I'll keep this in the background as well because we might refer back to it a few times. Again, as I said, in my background, I've got this running just to show you that, like for example, here is the virtual interface table. And you can see that, just refresh it, that there's no virtual interfaces that currently exist. And in terms of the customer table, you can see we just have Facebook, which has ID 3. So back here, we'll just go back to the main page. You can see in my overall dashboards here that I've got one internal member, which is the one that we had from the start, which is the one that represents your own IXP. We've got one full member, which we can see is Facebook. So let's have a look at Facebook. Now, we're going to give Facebook a connection to the exchange. I'm going to show you the manual way, which is not the way you will typically do this day to day, but it's important, first of all, to know that the manual way exists, that it gives you a little bit more control. It's also important to look at the manual way because it'll just reinforce that structure that we just looked at here. So we have a customer or a member, and we want to give them a new interface. So the first database object we need to create for that is this virtual interface. And in the manual way, we actually consider this in greater detail. In the automated way, we're really only concerned about adding the VLAN interface and the physical interface. So virtual interface in IXP Manager, when you look at interface ports over here in the left-hand menu, when you click on it, you're actually looking at the list of virtual interfaces. And we have none at all yet. I'm going to go up here and I'm going to add a virtual interface object only, which is the manual way. So I need to pick a member, Facebook. Again, remember that always in these pages you have context help. So in this case, I'm going to just pop this, I'll leave it on. 802.1q framing. Again, that is only really necessary if you're going to give the member multiple VLAN interfaces. So more than one VLAN interface. Why would you give a member more than one VLAN interface? We at INEX certainly have very little use for it these days, but traditionally, or historically I should say, the reasons that we had VLAN interfaces was back in the mid-noughties, we had a jumbo peering LAN, because that was sort of popular at the time, where rather than using a layer 3 MTU of 1500, you might have used a layer 3 MTU of 9000. In reality, that served little purpose, because at the end of the day, your customers, your end users on your network probably only have a 1500 byte MTU. So that didn't really go anywhere. The other thing we had was a VoIP peering LAN, which again back in the noughties was quite popular, and it allowed members to assign different quasi rules and stuff to traffic that went on that particular connection. It's not in use anymore, so we don't have it anymore. But there were two reasons why you might have had a second VLAN interface. Nowadays, the most popular reason to have a second VLAN interface is if you are giving two or more members a private VLAN between their own two networks, or two or more networks. So it's a private VLAN service. You might create a VLAN interface. A VLAN interface in a private VLAN service would connect to a VLAN representing that private VLAN, but it wouldn't have any IP4 or IPv6 address. That wouldn't be the concern of the IXP. So that's why you might have a tagged interface. Link aggregation, we're not going to look at that now, but obviously the reason you'll have that is if you have two or more physical interfaces. You can also use this to create a single member lag. Let's say you have a member come in at a 100 gig port, and it's quite common these days that they'll want to set it up as a single member LACP lag, both to ensure bi-directional traffic flow and also to allow them to upgrade hitlessly if they want to add a second interface to that. Under advanced options, and this is something that we're going to look at again later, it's more to do with like virtual interface name and channel group, or to do with lags. The MTU is important to note that this is a layer 3 MTU. Typically you leave this blank because it's 1500 bytes for all of your member connections. When we use this, and we'll see it down the road, is we typically use this for core interfaces. That's like, for example, VXLAN, layer 3 interfaces between our switches, where we might run those at 9000 bytes, for example. I'll turn off the advanced options and I'll turn off the help. So really, when we're adding this virtual interface, we're just picking the member and we're clicking add to kick us off. If we go back to our database now, what you'll see in virtual interfaces is we will see, and there it is, customer ID 3, which was Facebook, as a virtual interface. There's nothing else on this because it really is just creating that syntactic sugar in the database so that we can start giving the user physical interfaces and VLAN interfaces. So, I'm just checking my time here. Okay, so we're going to add a physical interface. Now, we added a switch back in one of the earlier tutorials, and that's that switch here. We're going to pick a port. We're going to pick Ethernet 1. Now, one of the things that's important here is you're only going to see ports that are either peering or unset unknown. And particularly, you're only going to see ports that haven't already been allocated to a different core or member link. When we look at our switches, I'm just going to open this in a new tab, and we look at switch ports, what you'll see is, did we set them? I can't remember. All right, so yeah, we have a port that's used for monitoring. So that's for quarantine purposes or diagnostic purposes, where we need to, with the member's permission and in consultation with them, grab their traffic and see what's going on. And then we have some core ports, which are inter-switch ports, for example, right? And we have a management port. So those types of ports aren't going to show up in our drop-down. Only ports that we've set up as peering or that we've set up as unset unknown are going to show up. There's some kind of CRUD information in here because I probably I think when we did this, I used a real switch to populate this. I think is exactly why there's some alias information in there. So sorry, right. So the important point there was on our switch port, once we picked our switch, the switch port dynamically fills with only ports that are not in use and of type peering or unset unknown. I'm going to give Facebook Ethernet 1. I'm going to say that they're in quarantine. So the options here are awaiting cross connect, and that's absolutely fine. For example, for if you know it's going to be a long time away and things like that. Quarantine is useful because it means that we can bring the port up, and you know, with fiber ports, single mode ports, LR, LX, it's very useful for the IX side to provision and bring up the port so that when the member is connecting to their kit, they can align the TX RX correctly and save a lot of hassle. So we would typically bring fiber ports up in quarantine straight away so that we can have that port enabled and transmitting light. Not connected is just not connected. Awaiting cross connect is awaiting the cross connect. Disabled is disabled. And connected, we only ever really use awaiting cross connect, quarantine, and connected. So I'm going to bring some quarantine. Speed is going to be 10 gig, full duplex, and auto neg. So again, if you turn on help, what you're going to get information on all of this, and we'll just turn it on. So the ports, again, suitable available ports, and we explained how that is unused peering or unset unknown ports. We went through the quarantine information ports, that's fine. So look, seriously, is half duplex even a thing anymore? Maybe it's time we took that away. I don't know yet. And again, unless you are provisioning switches from IXP Manager, which is something we will look at in the future, this is really just informational. But it's good and proper that you should try and make sure that reflects the actual state on your switch, so that when you do go down the road of provisioning, that you have less inconsistencies between what IXP Manager thinks something is and what the switch thinks something is. So I've added that port, and I can see that here, 10 gig full duplex, auto neg enabled. That's great. The next thing, again, if you remember from our diagram here, for virtual interface, we've got a physical interface, switch port switch. And in fact, if we look at the database, so it's virtual interface ID 3. And if I find my physical interface now, you can see this relates to virtual interface ID 3. And you can see speed is 10 gig, status is 5, which I think was quarantine, full duplex, auto neg is enabled. You can see that links to switch port ID 1. I can click on that in this. So in my switch port table, I can see that's Ethernet 1. It looks like, again, if you recall, I pulled this from a live switch, so there are some bits of information there which we won't worry about for now. And that's switch ID 1, sorry. So you can see now I'm in switch table. It's switch 1, that's its name, and it's on infrastructure 1, which was INX LAN 1, I think, if I remember. So you can see all those database entries have been created from what we've just done there. The next thing we want to do is we've done our physical interfaces and they've been linked to the switch port and switch. We're going to create our VLAN interface and we want to link that to a particular VLAN with some IPv4 and v6 addressing. So down in VLAN interfaces, I'm going to click add one. So I pick my VLAN. So because this is in quarantine, I'm going to pick quarantine LAN 1. IPv4, IPv6 are all enabled. Pick my IP address. Oh, I think that is probably because when we were provisioning this, did we add addresses to, just going to copy this, quarantine LAN 1? We did not. That's fine. What that might help us do actually is just see a different feature. Did I go back and go back and go back? Okay, let me just reload this page. So we got quarantine LAN 1. Let me just reload it properly. So we got quarantine LAN 1, IPv6, IPv4 enabled. So I'm going to leave all this off for now. So I'm going to pick an IPv4 address. I'm going to pick it as 10. What we see here is that I don't actually have any addresses. One thing you can do with IXP Manager is you can type in an address and it will add it to the database for you. So I'm matching the last bit of the v6 address, which is 10, to the last bit of the v4 address. I want to give it a host name, so we call it INX. Let's call it inex.fbnet.com, and we'll do the same here. Maybe I want to distinguish IPv4 from IPv6, for example. Let's create some MAC address or some MD5 secrets. When you do this inside IXP Manager here, this uses a cryptographically secure random generator from within your browser. So IPv4 and IPv6 ping allowed. and monitor root collector BGP session. So what they are is they're just flags in the database for now. When ping is allowed, what that means is that if we want to do packet loss and latency monitoring through smoke ping, that will add these IP addresses as a target and smoke ping down the road again. We'll see that later. At INEX, we have a mandatory, we require a mandatory peering session with the root collectors from all of our members. And the monitor root collector session creates Nagios configuration, automated Nagios configuration that adds that to our monitoring as well. And that's incredibly useful for things like maintenance, so that after maintenance, we can check Nagios and make sure that all of these things have come back up. I think that's everything I need. I'm going to go ahead and add that. So that's great. You can, if we go into IP addresses now and IPv6 addresses for quarantine, you can see it added that in there for us as well. Oh, silly me, I put v4 for v6. Okay, that was obviously a mistake. And in fact, why don't we just go in and edit that just to show you that that is possible. So I take, oh no, v4 is right. There might be a bug there. I'm just going to take a quick screenshot myself for later. We might be pulling the host name from the v4 side when we're adding a v6 entry. So I'm going to put that in like that. It might also be a bug on the display side, so we'll have a look. Actually, that's one of the useful things to do in these video tutorials is I'm very much used to doing things a very specific way with INEX. I can kind of do it with my hands tied behind my back, but when I do it for these video tutorials, I do it much more methodically, and I actually pay attention to a lot more of these kind of things, these kind of bugs that might crop up. So, okay, we've done all of that. We've added our interface. If we go back and we look at Facebook, we can now see that they have a port here. On the overview, we can see that there's a graph. These are all dummy graphs. Again, we're going to come back to graphing in a future video tutorial. But we can see that the port's there and all the details are there in the ports tab. What I want to show you, and what I went to show you in the last tutorial was about the API, and I went in here to show you that Facebook, or that our Facebook would be in a member list, and you can see here it still isn't. And the reason it still isn't is because we put that port in quarantine, and quarantine ports aren't going to show up in the export because they're not live. So let's make this port live now. So to make it live, I'm going to put in connected state. And the other thing I need to do is swap it from the quarantine LAN to the production LAN. And one thing we should see here, hopefully, is that all of this information is retained. It matches the addresses and stuff. Great. So you can see all that worked. And save that. And all I did was change the VLAN, and I've kept this information. So it makes it easy to swap ports in and out of different VLANs when you're quarantining and things like that. So sorry, if I reload this now, and here we go. In our member list, we now have Facebook. I'm getting more information here. I'm getting things like contact details because I'm logged in to IXP Manager. IXP Manager knows I'm logged in. If I wasn't logged in, I wouldn't get some of this information. So you can see for Facebook, I've got my AS number. I've got the name as we recorded in IXP Manager. I've got the peering policy that we use in IXP Manager. And as I go in my connection list, I can see he's connected to IXP ID1, which is recorded up here in the IXP list. He's connected to switch ID1, which again is above in the IXP list at 10 gig. I can see he's on VLAN ID1, which again is up in the IXP list. So this is all kind of self-referential in the schema. And now I can see his IP address, the AS macro, I can see the max prefixes, the IPv6 address. So you can see all of the IXF member export schema stuff starting to build up as we add this information to IXP Manager. We're not, as I say, in a future version of IXP Manager, we're going to get into the weeds and graphing, but again, the graphs are there. We've got the dummy backend turned on, which just gives us this kind of visual feedback without having kind of blank or error boxes. But once ports are working, you can see for Facebook's port on switch I1, Park West 1.1, Ethernet 1, we've got day, week, month, and year graphs for bits, packets, errors, discards, and broadcasts. I can look at all the ports. So if they had more than one port, the aggregate would show me the aggregate of all of their traffic at the exchange. And we'll see later how this affects lags and stuff as well. And then I can drill into these. I can see the aggregate bits and all that kind of stuff. So let me just edit the VLAN interface again just to run through some other things just quickly. So we skipped this section, and let me just say a few words about this. And again, remember, there's lots of help available in all of this stuff. The max BGP prefixes, the 500 comes from the fact that when we added Facebook as a member, we set their max prefixes to 500. And it copied that, when we provisioned the port, it copied that in here. We could have left that blank, by the way, in which case it would take it from the master customer record. That's something that we need to consider in IXP Manager and with some more detail is, should we have the master with the interface stuff, and is that confusing that you can set it in two places? I think it is, but I need to figure out the best way of solving that. For now, we could override the master by saying this particular session will have 600, for example. Root server client, if we check that box, again, when we go down and look at root servers in a future video, what that means is that when we generate root server configuration, we'll generate a client configuration for this particular v4 and v6 address with these MD5s. Apply RDB filtering means that when you do generate root server client information, that you'll also use the IRDB database to put strict filters on the routes that can be advertised to the root server. Obviously, you want to always leave that on. The allow more specific means if, for example, Facebook had a /16 route for a v4 range, if they advertised that as 2/17s, the allow more specifics would allow that up to a /24. Ideally, members would create root objects or even better, or PKI entries that would reflect their actual routing policy. But sometimes there can be large organizations that have a lot of prefixes that even internally in their own organizations, it can be very hard to get that kind of thing done, in which case you might want to allow more specifics. And again, at INEXT, we have an AS112 service. And if we check that, it means that when we're automatically provisioning the configuration for the AS112 router, we'll add a client config again for these addresses and MD5s. Facebook are unlikely to want a pure AS112, so I'm going to leave that one off. So I can save that settings again, and what that means is down the road, when we regenerate those router configurations for the root servers, for example, we'll add Facebook to it. And on the member overview, you can now see green for RS client and red for AS112. Okay, so that was the manual adding of an interface with some graphs, how it affects the IXF member export, how we can edit root servers, and how we can switch between, for example, quarantine and production VLANs. The more typical way that you would add an interface to IXP Manager is you'll use the automatic wizard. So when you're in your member overview, you've got a provision new port option here. And when you do that, you get this add interface wizard. You can see Facebook's already set. You can choose your VLAN. So rather than going through the quarantine on this one, I'm just going to go straight into INEXT LAN 1. Going to enable v4, going to enable v6. I'm going to pick my switch. I'm going to pick the next interface. Connected 10 gig, full duplex, root server client, allow more specifics. I'm going to just take the default for that. I'm going to pick the next available IPv6 address, the next available IPv4 address, starting from next available being from 10 where we started. We normally keep the first few in the range free for things like root servers and AS112 and root collectors, and similarly maybe the last few free as well for kind of our own infrastructure. You can see that this normally will just copy this one. You typically don't want to have different MD5s. And in fact, for a lot of members, what we would do is we would take the MD5 from an existing port. Like so we have Facebook's here, right? We'd actually take this just to make life easier and not let them share that across a number of connections. Let me add that. So now what we can see here is we have our second interface, and with the wizard we in the last time we added a virtual interface, and then we added a physical interface, and then we added a VLAN interface. With the wizard we get to do all of those in one go, and that covers sort of your 90% use case, where even if you're adding a lag or multiple VLAN interfaces, you still want to get to this point before you can do all of the other things. So this really covers, using the wizard gets you to the place you need to be. For the other 10% of connections you might turn up, that might be more than just a simple connection to the exchange. If we return to Facebook, we can now see that they have 2 connections, the INX LAN 1. And if we have a look at their overall graphs, you can see we've got the aggregate peering graph again, which would be the summation of both of these. And then we have these 2 individual ports. So the next thing I want to show you is we've kind of covered adding the virtual interface, the VLAN interface, the addresses in the VLAN, and the physical interface, switch port and switch. We've done that twice now using both different methods. I now want to show you the situation of having a lag, so multiple physical interfaces to create one connection. So that's where a member might have, say, 2 or 3 by 10 gig to create a 30 gig interface into the exchange. And the way we handle that in IXP Manager is we find the interface that they want to lag, and we simply add a second physical interface. So again, we pick the switch. Let's say they're connected to port 3. This is connected at 10 gig, full duplex. We'll turn on auto neg for a crack. And now we'll come back to that warning in a second, but now what we see here is, right, now they've got 2 physical interfaces. Okay, the warning we're getting is that lag framing is not set, but there's more than one physical interface. This may be intended, but it should be verified. I'm trying to think why that would be intended right now. I can't think why it might be intended, but we definitely didn't intend it here. So we're going to turn on link aggregation lag framing. And then this is the option to use fast or slow LACP, typically fast. Again, in IXP Manager, all of this is just creating the member profile for administration, billing, accounting, tech support, and all that kind of thing. If you're configuring your switch manually, what you do with these boxes isn't going to affect anything, but it really should be done to match your actual physical environment. When we're doing provisioning down the road, this stuff is much more critical, because at INX, when I click fast LACP, if I turn that on, if I go and push config out to a switch, that will have a configuration effect. The other thing I want to just turn on here as well, advanced options. So again, these are all still blank. But watch what happens when I save this. Now, what's after happening is, first thing you'll notice is advanced options is turned on automatically. And it's turned on automatically because this is a lag port and this other information is suddenly important. What's also after happening is I've got a virtual interface name of port channel. Now, where did that come from? Where that came from is IXP Manager knows that this switch is an Arista, and in our vendors, under Arista, I've got a bundle name configured for Arista, and that's port channel. And that's where that port channel came from. Now, why is it port channel group? Why is it port channel 1? Well, what IXP Manager did, and again, this is why it's important that IXP Manager matches your physical environment. IXP Manager went and checked all the port channels in the database. There were none, obviously, which is why it's 1. And it found a free one that it could use to allocate to this connection. And that's where channel group number 1 came from. I can, of course, change that to anything I like. I can change that to 5, for example, no problem, or 6 as I typed. And that's fine. If port channel 6 was in use for this particular switch, IXP Manager would warn you about that and tell you you can't have that particular port channel. Excuse me. The other kind of small wrinkle we found is that some switches require space between the bundle name and the number, and to accomplish that, you just put in inverted commas. And while you'll see the inverted commas here, you'll see what the actual bundle name as will be configured through auto provisioning will be shown to you here. So that's port channel space 6. Of course, that's the more unusual case. We'll just put that back to our nice happy default here. So that's, you can see how you do lags. And again, there's absolutely no problem here if you wanted to add yet another lag. Connected. And if you were automating your provisioning out to your switch, when you add this in and push it, it would add the next port into the bundle. And obviously that would be a fairly hitless operation, because the other side, the member side, would need to be configured and participating in the LACP on that interface before it's added to the overall bundle on each switch. I'm just going to return to the member overview here for a second, and now what we see for that connection, it's got a little bit more complex. This connection one has 3 ports in a lag. You can see those here, and then you can see the layer 3 addressing here again. If we look at the graphs, in fact, let me look at the all ports graph just to show you. So we've got our aggregate as we had before. What you now see is this lag is broken into an aggregate for the lag, so we can see the overall traffic on that 30 gig interface, plus we can see the individual lag ports. And that's useful because it'll show you if traffic has been correctly balanced across all the ports, for example. And then that was our second port that we added earlier on. One thing I might just show you is the case for a second VLAN interface. So for private VLAN, I don't know if we added a private VLAN back at the start. We didn't. Let's say Facebook come to us and they tell us that they want to have a private VLAN interface with another member. So we would create a private VLAN, let's call it PV, and call it, let's say, Facebook and AN, some other network. And we're going to start that tag at, say, 3000. It's going to be an INX LAN 1 infrastructure. Config name is PV FB AN other. So it's sort of what we would call that on switches that require a name for a VLAN. This is a private VLAN between a subset of members. We're not going to include it in peering matrix. We're not going to include it in the peering manager. It's a private VLAN. We can add that in there. What you can see here is that says yes for private. You can also look in a case where you might have many private VLANs. You can look at them as an individual view here. Let's pop back to Facebook and let's go to the ports. Let's edit this second port here, for example. So let's add private VLAN. Here we go. Nothing else matters in any of this here, because the exchange has no business in any layer 3 configuration over the private VLAN. We don't assign IP address or anything. That's an absolute issue between the two members concerned, the 2 or more members concerned. So there you can see that there's a private VLAN, and there's actually currently an issue open in IXP Manager that we have 2 VLANs added. If you remember when we added the second interface, we got a warning saying that link aggregation wasn't enabled. Similarly, we need a warning to say that use 802.1q framing, because obviously if you have more than 1 VLAN, then we absolutely need to do need to make that port tagged. So that is the private VLAN. And just one other thing to point out is that when we've added that, you now see suddenly a new tab has appeared, and what this would normally show us is the other members that would participate in that private VLAN. And Facebook themselves, when they log in as users, will be able to see this information as well. There's just 1 or 2 things I want to cover off, and I'm conscious that we're at 40 minutes now, so it's getting long. One thing that I just want to mention very briefly, I didn't talk about this multicast or busy host. Again, this information is available in help, but multicast enabled is kind of legacy. It's INX dabbled again. We're back in probably more in the 90s than the noughties here, allowing members to enable multicast between peers on the exchange, and very few exchanges at all do this these days. It's quite complex, so that's very rarely used. Again, that would be more of a provisioning flag when you're pushing config to the switch to say you need to configure some multicast stuff here. Otherwise, it's informational in IXP Manager. Busy host is because when we enable pings for v4 and v6, as most of you will know, routers tend to deprioritize traffic that's destined to its control plane. And when you're pinging your router, you're essentially trying to access its control plane to elicit a ICMP echo response. Because that traffic is deprioritized, busy routers, especially CPU routers that switch in CPU rather than in hardware, we may get very high latency to those ping responses. Sometimes it could be a couple of hundred milliseconds. And our default Nagios config in INEX will warn us if we start getting high latency responses from routers. It might indicate might give us some foresight or forewarning into member issues and things like that. Where a router consistently gives us those alerts, we turn on busy host, which means that we turn Nagios up to say, look, if the response is less than 2 seconds, it's fine. And that's all that means. It just means that host is typically busy, or it's routing in CPU or forwarding in CPU. So that just turns off that kind of noise that we might get in our NOC at INEX. The other thing I wanted to show you, and again, it's what I mentioned on our graph here, was these layer 2 addresses. So that's this configured MAC addresses. That's what the layer 2 addresses means. And at INEX and at many exchanges nowadays, IX operators configure static layer 2 ACLs, and that's to protect the switching fabric. So it means that packets Ethernet frames can only be originated into the exchange from a member as long as a source MAC address is configured here. And to add a MAC address, what we do is we click this. You can add an address. Now this is pretty forgiving, so you can copy and paste pretty much any switches or any platform's MAC address format. It'll strip out all of the crud in the middle. It'll just give you a nice, simply formatted MAC address. So I can pop back to my virtual interface here, and there's my configured MAC address. What we would do at INEX, that is used for automated provisioning. So we push that out to the switches, and we create static layer 2 ACLs based on the MAC address configured here. We have a very strict rule of 1 port, 1 IP, 1 MAC, 1 IP v4 v6. It's really 1 VLAN, 1 MAC, 1 IP4 v6. But sometimes a member may pre-warn us that they've planned maintenance to change a router, and they might give us the new MAC address. In that case, we would temporarily add a second MAC address, and whatever it is that they told us it was, add that in. So we've got 2 MAC addresses. Go back here, and you can see it's kind of in yellow here. It's kind of warning us that there's multiple MAC addresses configured here. It's multiple, meaning that that's not really a standard config. So we come back in here again. Then when their maintenance is confirmed, their maintenance is over, we might remove the old MAC address, and then they're left with just the new MAC address. Now that is pretty much what I wanted to cover today. That is the theory of how interfaces are represented in the database. We had a look through how they worked here, and what we didn't actually look at one stage was the VLAN interface, but you can see now there's 3 VLAN interfaces because we gave virtual interface ID 4 a private VLAN, and you can see that private VLAN doesn't have any v4, v6 addresses or anything else. You can see how these relate back to the virtual interface ID, how they relate to IPv4, IPv6 addresses, and how they relate to VLANs. So we went through all of that theory. We did adding VLANs the manual way and the automated way. We kind of had a look at how that would roll, we had a look at sort of a preview about how that will flow into graphing later for ourselves. We talked about how a lot of this stuff will relate to provisioning down the road. We looked at lags and how they're represented in IXP Manager, the layer 2 addresses. The one thing we haven't looked at, and just to give you a look at it, is how you might delete a interface. So let's say we want to delete this interface, and the delete interface is normally hidden away in advanced options. If I click delete interface here, it's going to delete all the interface details for this. And yes, I do. And there it's gone. So Facebook is back to just one interface now. So I hope that was useful. Again, just as a reminder, we do have docs.icpmanager.org, And on that, you will find under general usage, you will find a section called customer connections. There's a little bit of a database graph here, which is what I showed you through the presentation. It talks about how all of that stuff is connected, provisioning an interface via the wizard. So a lot of the stuff we went through. There's some information about what each one does, and again, that's probably covered as well in the help, the inline help that you get on all of our forums. Again, remember, sorry, that interface has just been deleted. Go back to, oh, sorry, I'm going to go to Facebook. I want to go to here, edit. So again, it's just a reminder that every single page comes with this significant amount of inline context help. So physical interface settings, general VLAN settings, v4, v6, viewing, editing, and interface, virtual interface details, physical interfaces, VLAN interfaces. So it covers a lot of what we went through, but obviously this video tutorial again goes into much more detail. So hopefully that will be a lot more useful. So that's it for me for now. Thank you for your time, and I will talk to you all again next time. Be safe.